Hello, thank you for watching this video. So in this video, we'll be doing question 3 of May, June 2023 question paper Physical Sciences paper 1. So these are the projectile motion. So I'm going to read question 3 statement and then answer the questions that follow. So let's go. Question 3. Ball A is dropped from rest from the top of a building 15.2 meters high. After ball A has fallen 3.2 meters, a second ball, ball B, is projected vertically upwards from the ground. After a while, the balls strike the ground at the same time, right? Ignore the effects of air resistance. So let me read this thing again. They're saying ball A is dropped from rest from the top of a building 15.2 meters high. After ball A has fallen 3.2 meters, a second ball, ball B, is projected vertically upwards from the ground. After a while, the balls strike the ground at the same time. Ignore the effects of air resistance. So what we have here, we have ball A, which is dropped from the top of this building. Here is our building here. This building is 15.2 meters high. So after this ball has fallen from its starting position from the top of the building, which is 15.2 meters high, after it has dropped a distance of 3.2 meters from that 15.2 meters height, a second ball, ball B, is projected vertically upwards, right? It is projected vertically upwards. So, but then we're told that they reach the ground at the same time. So what happens is this one is released, and then after it has dropped to this height or dropped with that displacement, the second ball is projected upwards, and then these two balls then hit the ground at the same time. So they want us, what do they want us to do? So at 3.1, they want us to define the term free fall. So they want us to define the term free fall. So what is free fall? So free fall, I defined it in the previous question, which is question 2. So free fall is the type of motion in which the only force acting on that motion is gravitational force only, or force of gravity only. So it is the type of motion in which the only force acting or the only force influencing the motion is the gravitational force. That's free fall. I'm not sure if I have to write that down. Free fall is the type of motion in which the only force influencing the motion is gravity. So an object is said to be in free fall if the only force influencing the motion is gravity, which is the only force acting on the motion on the object during that motion, or the object in motion. So that is free fall. Then we'll move on to 3.2. So what are they saying in 3.2? They are saying calculate the time taken by ball A to strike the ground. They want us to find the time it takes for ball A to strike the ground. So when you're doing this kind of stuff, it's important to have a coordinate system. So for ball A, I'll take downward motion as positive and upwards motion as negative. That will be for my ball A. So I'm taking the downward motion to be, actually, no, let me keep it the standard way, or my way that I like it most. The downward motion as negative and the upward motion as positive. That's how I'm going to do it. Which means my downward velocity will be negative. My upward velocity is positive. So the point where my ball is starting, I take it as a zero reference, right? So all displacement below are negative and all displacements below above are positive. So if we want to calculate the time it takes for ball A to hit the ground, so we can say, okay, what do we know about ball A? We know the initial velocity of ball A. We said ball A is dropped from rest, so its initial velocity was 0 meters per second. So we know its displacement, right? What is this displacement? So its displacement, it has been displaced from there to the ground, right? From that 0 point to the ground. So it's going to be 15.2 meters. Is it positive or negative? It's negative because I said everything below my starting point, I take it as a negative. And everything above, I take it as positive. This is what I said with these two arrows. So all the displacement above is positive and all the displacement below my starting point is negative. So what is my displacement? Our displacement is minus 15.2 meters. We have the gravitational acceleration, which is 9 minus 9.8 meters per second. Right? So now what we want to find, we want to find the time ball A takes to reach the ground or to strike the ground. That's what we want to find. So how do we do that? We say, okay, Vf squared is equal to Vi squared plus 2a delta y. So what we're going to do here, we want to find the velocity at which our ball strikes the ground, right? Once we find that velocity at which it strikes the ground, we will calculate the time it took for our velocity to move from zero velocity to whatever that velocity will be. So okay, Vf squared is equal to Vi squared, which is your 0 squared, because the initial velocity was 0, plus 2 into minus 9.8 times the displacement, which is minus 15.2. So the square of the final velocity is equal to the answer to this. So I'm going to punch it on my calculator and see what we get. So we have 2 times negative 9.8 times minus 15.2. So we get 297.92. So our final speed will be square root of that, which is 17.26 meters per second. So what we have here is the final velocity at which our ball A will hit the ground. So ball A will hit the ground at a velocity of what? Of minus 17.26 meters per second. So you can just say negative because it's downwards. But let's not have that, but it's fine. So we can say downwards. So this is the velocity at which our ball hits the ground. That's what we have. So what do we do from here? So now we need to find the time it takes for our ball to accelerate from 0 meters per second to 17.26 meters per second. That's what we need to find out now. The time it took for our ball to accelerate from the velocity of 0 meters per second, which is initial velocity of 0, to the final velocity of this. And then, because we know that this is the velocity at which our ball hits the ground, that time it took to accelerate from 0 meters per second to that velocity, it will be our time it took the ball. It will be the time it took for ball A to strike the ground. So what we do is, okay, Vf equal to Vi plus A G delta T. The final velocity is minus 17.26, because because the velocity is negative downwards, right, is equal to our initial velocity, which is 0, plus negative 9.8 delta t, which is the time that of the motion, then divided by minus 9.8 divided by negative 9.8. So delta t is equal to, this is 0, so you can write it off. This divided by negative 9.8, what do we get? We get that it's 1.76 seconds. So, in summary, ball A had an initial velocity of 0 meters per second and then hit the ground at that velocity of 17.26 meters, 26 meters per second downwards, right? And then we found the time it took for the ball to accelerate from 0 to that velocity. So this falling object took 1.76 seconds to accelerate from 0 to that velocity, and this is the velocity at which it hits the ground. So that is the time at which our ball took to hit the ground. So we're done with this question. So we'll move to the next question, which is 3.2.2. Let's go. What are they saying? They are saying, calculate the magnitude of velocity B with which ball B was projected from the ground. Right? So they want us to find the velocity of ball B. That's what they want us to find. They want us to find the velocity of ball B. How do we do that? We say, okay, what we can do is, we can calculate the time. What we can do is, because what we're told is that this ball was dropped from rest, right? And then when it was 3.2 meters below where it was dropped, this ball B was projected, which is this one. It was projected vertically upwards. And both balls hit the ground at the same time after that. That's what we're told. So now, what they want us to find, they want to find the initial velocity of ball B. How can we do that? What we can say is, okay, we can find the time it took our ball to move from position A to travel this displacement from its starting position. We can find that time, right? Then, after finding this time, the time that we get, we subtract it from, okay, let me just do it. We'll find it on the way. So what we can try to do, we can say, okay, ball A traveled this displacement of minus 3.2 meters, right? Its initial velocity was 0. So what I'm interested in is finding the time at that position there, how much time it had traveled to that position. So I would like to find time. So how do we do this? Say, okay, delta y equal to vi delta t plus half g delta t all squared. So the displacement is minus 3.2 is equal to vi initial velocity, which is 0, times time, which is what we're looking for. Because we want to find what is this time between this point and this point here. We want this time here. Plus half negative 9.8 times delta t, which is, say, delta t squared. So your minus 3.2 is equal to, this would be 0, 0 times t is 0, minus 4.9 delta t squared. Divide by minus 4.9, divide by minus 4.9. So this and that go away. Then you say delta t is equal to what? Punch that and see what you get. So you say minus 3.2 divided by minus 4.9. So the lattice squared, because it should be the square of the time, is equal to 0.65, and then take the square root, then you get that your time is equal to the square root of this thing, which is 0.81 seconds. So for ball A to move from its starting position, which is on the top of the building, to travel this displacement 3.2, it took the time of 0.81 seconds. Right? So ball A from its top of the building to travel this displacement, which is 3.2 meters here, it traveled that 3.2 meters in 0.81 seconds. Right? So if you subtract the entire motion of ball A by that time, which is 0.81 seconds, it will give you the time from this position up until it hits the ground. And this time that you'll get here is the time at which both of these balls were in motion together. I'll try to repeat this. So 0.81 seconds is this time over here, from the top of the building to travel this 3.2 meters, which is this distance over here. Right? And then now, you know that the entire motion of ball A from the top to the building is equal to what? 1.76 seconds. So now, if you remove that 0.81 seconds, the time it took to travel that 3.2 meters per second when it was initially dropped, the time that you're left with is this one, from here up until to the ground. And that time is the time in which ball A and ball B, because when ball A was here, this one was released. So this is the time at which both balls were in motion. So I can say now, ball A and ball B were in motion for what time? For time for ball A and B was equal to 1.76 minus 0.81. So the answer to this is the time, the duration of the motion in which both balls were participating on. So the time that you will get here is the time in which both your balls were in motion. Because this one is the entire duration of ball A's motion. But on its own, ball A only traveled 0.81 seconds, which is from that top of the building to travel that 3.2 meters. So this time that you'll get here, the answer to this, which is 1.76 minus 0.81, which is 0.95 seconds. This is the time at which both balls were in motion. This is the time for both ball A and B in which they were in motion. No problem. But what do we want? What we want is the initial velocity of ball B. But what we can say is that the entire motion of ball B, the entire motion of ball A, which B, to move from this back to the ground, which is maximum height, is what? Is 0.95 seconds. Which means to go up, it took half of this, and to come down, it took half of that. So, which means if we split that time of ball A and ball B, which is now, let's say if we split the time for ball A in half, we'll know how much it took to get to the maximum height and how much it took to return to the ground. So let's split it. So let's say T for the time for ball A, for ball B, is equal to 0.95 seconds. So this ball B, the ball B took half of this time, which is 0.95 divided by 2. So it took 0.48 seconds to go up and 0.4 seconds to go down. That's what ball B did. We want its initial velocity, but at the maximum height, we know its final velocity was 0, and we know to get there, it took this amount of time because it's half the entire duration of the motion of ball B. So what we can say is, we can say, okay, Vf is equal to Vi plus A delta T, right? We know its initial velocity is 0 at the maximum height, which is at this point here. And its initial velocity is what we're looking for, plus negative 9.8 times the time it took to reach the maximum height, which is 0.48 seconds. Therefore, your initial velocity is equal to, you transpose this to the other side, say this times 9.8. You get that your initial velocity was 4.66 meters per second. Per seconds. They want the magnitude, you can say upwards. They only wanted the speed, but you can also give them the full velocity. So this was the initial velocity of ball B. So ball B was operated at 4.66 meters per second. And I hope it does make sense to you as it does to me. So I'll go to the last question, which is 3.3. So I'll clean the space here and do 3.3. Next one, we can do 3.3 there. So what are they saying at 3.3? They're saying, on the same system of axes, draw a position time graph to show the motions of both ball A and ball B from an instant ball A was dropped until when it reaches the ground, right? Take the ground as a 0 position. Label the graphs A and B. Clearly indicate on the graph the starting time of each ball, the initial position of each ball, the time when the ball strikes the ground. So they want us to draw a position time graph. So let's try that. So this is 3.3. Position, you can say maybe time. This is 0. This is the time in seconds, right? This is the position in meters. This is the position. So ball A is released from rest ball A, right? So we should say your ball A just dropped. This position, I'm not very happy with this. Yeah, so you can say ball A something like this. This is the motion of ball A, right? Ball B was projected what? 0.81 seconds later. So we can say at 0.81 seconds, ball B was only, yeah. So it was projected up, then went down. So it should be something like this. Up, down. This is your ball B. So what do they want? The starting time. So here's starting time for A, here's the starting time for B. And then what else? Initial position, this one was 15.2 meters above the ground. This one was exactly at the ground. And then they hit the ground here at 1.76 seconds later. Starting time for each ball, initial position for each ball, the time it takes for the ground balls to hit the ground. So it should look like something like this. So this is how I would draw the position time graph with this thing. And then I think I'm done here. And I hope this question does make sense to you as it does to me. Thank you for watching. Cheers.